In the previous video, we ended up with this problem. X is greater than 1, and we shade to the right of 1. 1 has an open circle because it doesn't read equal to, it just says greater than 1. Alright, now I want to introduce to you the interval notation of representing these graphs. And let me just write it out. In interval notation, we would write x is an element of or belongs to parentheses 1 comma infinity, close parentheses. Alright, so this is a shorthand notation, and this is called an interval, and this stands for all the numbers from 1 up to infinity. Now the lazy 8 symbol, if you're not familiar with that, that's the infinity symbol. And I have a parentheses here because we're not including 1. And so always use a parentheses when you're not including the number as an equal to. Infinity always gets a parentheses symbol next to it because you cannot close off infinity. So infinity always, no exceptions, has a parentheses. But this number has a left parentheses because x is greater than 1. If this read greater than or equal to 1, then I would use a bracket symbol next to the 1. I'll show you one of those momentarily. This symbol here is the element symbol in mathematics. Please don't write it as an E. I might count off. Alright? This is not the same as x, E, 1 to infinity. Don't do that. Alright? And also please don't write another E. Okay? It's not E. Trust me. This is the element symbol. And in fact, if you know Greek, it's not even the Greek letter epsilon. So it's the element symbol. And you might think in less formally that it means x belongs to or is a member of. So x belongs to the interval from 1 to infinity is how you could translate this into a little less formal language. Alright, now while I'm thinking of it, your textbook often writes things in what's called set builder notation. And so it might write an answer in set builder notation this way. And here's how it looks with all the bells and whistles. To interpret this, this reads the set of all x's such that x is greater than 1. Okay, so this is this interval written in set builder notation. Quite honestly, I just don't like it. I just think it's a little pompous and a little too formal for our needs here. So I'm not going to worry about set builder notation. You don't have to do that for me. I think you'll find some answers in your course textbook are probably written that way. And but I don't do that. But I do ask for interval notation. Interval notation is not just used in this course. You'll see it in college algebra if you take that. If you take a statistics course, we might use interval notation to represent confidence intervals. Certainly calculus, you have intervals of convergence. We use interval notation there. And so it's a very common way of representing inequalities or ranges of numbers. Alright, now let me do some more here. Let's have a less than or equal to. So suppose that we have x, we solve a problem, we end up with x is less than or equal to 2/3. Alright, now where am I going to put 2/3 on the number line? Well, how about here? Easy enough? Okay, again, I'm not going to worry about you putting a bunch of scale marks on these things and numbering the scale marks. Now we will encounter some of these in the next section where you will have two numbers on the number line, so you have to make sure the small one goes to the left, the larger one. But here's 2/3, and do I use an open circle or a closed circle? Closed circle, because it says it's also equal to 2/3. So a closed circle, and I shade which direction? X's are less than 2/3, so all the numbers less than 2/3 are to the left of 2/3. Now here's how it looks in interval notation. We would say that x belongs to the interval from parentheses, negative infinity, comma, 2/3, and then I put a closed bracket on it. So the bracket symbol represents the inclusion of the endpoint. In this case, the inclusion, it equals to 2/3. So brackets for equals, and parentheses for just strictly less than or strictly greater than. Negative infinity, that's on this side. So actually your number line stretches to infinity on the right side and beyond, and on the left side to negative infinity and beyond. And so over here is the negative infinity side. All right, so there's interval notation, and I expect you to write this stuff. Okay, if you're going to use interval notation, let's use it properly. Make the element symbol, don't write an E, and don't forget your variable. If we solve the inequality and got y instead of x, then put y there. The y is belonging to the interval would be the statement of the solution. So that's interval notation.